cleaning and all. We'll have a just review of what exactly the data cleaning and all. So data cleaning is data cleaning is known as data cleansing or scrubbing. Okay, it is the process of detecting and correcting or removing the corrupt or inaccurate records from the dataset and identifying and handling the anomalies. So exactly, it is cleansing or scrubbing. Okay, and it is a process of detecting and correcting, and it's about preparing raw data for analysis by making it consistent, complete, and correctness. Like think of like a quality control process for your data, ensuring that the information you're working with is trustworthy. Okay, so that is the main reason of the data cleaning. So why it is important, why it matters to us? So the phrase like garbage in, garbage out perfectly encapsulates our importance of the data cleaning. If the data you feed into your analysis or machine learning models is flawed, the insights and predictions you get also will be flawed. So regardless of how sophisticated your algorithms are, your output will be flawed. So in critical fields like robotics or healthcare, as they are our main focus of applications, in these cases also, dirty data can lead to serious consequences such as robot making an unsafe maneuver or a medical diagnosis being incorrect. So that is important. So if you're not making the garbage out, okay, and if you're not making the garbage, whatever their garbage is there, and if you're not making the cleaning, then what happens? Obviously, all your analysis and machine learning models, everything will be flawed. Okay, so that is the main reason of going for this cleaning before starting any process. Okay, so data cleaning is detecting, correcting, or removing corrupt or incorrect, inaccurate, or inconsistent records. Okay, so we cleanse the data, ensure safe robot and correct medical diagnosis as per our applications. So dirty data will leads to the big risk like faulty robot movement, wrong medical diagnosis, unreliable models, machine learning models, which whatever we do, that will be getting wrong information, wrong models we may have we may design. So what are the common data issues like missing values, duplicates, inconsistencies, outliers, and noise? All these are the common categories of the data issues. Okay, what is this missing value? When we are getting the data, okay, collecting the data, some data points may not be collected or they may be lost. Okay, or they often may appear as null or NaN, not a number, or an empty cells. So missing values are the data which may be not collected or they were lost. Okay? And they may appear like null, NaN. NaN means, not a number. Instead of number, we try to enter some text over there by mistakenly, then it will show us the NaN. So, or an empty cells. All these we call as missing values. Then other data issues like duplicates. So identical records that appear more than once in the data set, that we call as duplicates. Okay, any records that appear more than once in the data set, that we call as duplicates, including different spellings like say for you're collecting from 2 to 3 sources of the data, and for For gender, some people are maintaining as M, F, or O. That means male, female, or others. Some are maintaining the data in terms of the male, female, or others. Like directly they're writing male, female, or others. In these cases, when you're combining the both the data, same data is represented in terms of the M, and same data may be represented in terms of the male. So like metrics versus feet, meters versus feet, same data, maybe some data we collected that is represented in terms of the meters, and some data may be collected into the feeds. So what we may do, because they both are not equal, we may think that they are different data, but the origin may be same, but they are represented in different manner. So what we have to do, these we call as inconsistencies. These we call as inconsistencies. So missing values, duplicates, which are identical, which appear more than once in a data set. Inconsistency is data that doesn't follow a standard format. Example include different spellings, like all different units, or verifying the data. So all varying data formats, all these we call as inconsistencies. So same data may be represented in different manners. Okay, so that we call as inconsistent. So what we have to do, we have to, while cleaning, we have to generalize those data. We have to manage. So M, if you are maintaining M for male, we have to maintain all M only for all the data which related to the gender when it appears male. Or if you want to maintain F for female, then we have to maintain F only for. So that occurs when we are pulling the data from different sources. We have to clean all those data. Then the other important is outliers. These are the data points that are significantly different from the rest of the data. Okay, these we call as outliers. So if something is happening, say we are analyzing the temperature, but somewhere some record due to the sensor issue, it may record some 50 degrees Fahrenheit. Okay, then it may be outlier. Normally it ranges from the 20 to 35. Then suddenly some data is 50. Then we call it as outliers of which are not from the rest of the data. Okay. Divya, see that all the thumbs, please stop for a while. Then we can continue, because it is disturbing the class. Thumbs, please stop. Divya.
Yes, sir. Yes, sir.
Then when I
Couldn't
ask
me.
question, you can control from your side. When there is when I ask question, you can allow them for the questions or thumbs or anything. Okay.
Okay,
So
sir.
outliers are the data points that are significantly different from the rest of the data. They can be genuine but rare observations, or they can be errors from faulty sensors or a data entry mistakes. So that we call as outliers. So they may be different from the common data. Say we are talking about the marks. Marks may be from 30 to in between 100. But someone, if he gets 120 or 130, that is an outlier. Normally, no one gets a 130 per 100, right? So that is an outlier. That is a mistake. Or everyone is getting from 30 to 40, 30 to 70, but someone is getting 99.9. So that is an outlier. Someone is so that is an outlier which is not like common behavior. That we call as outlier data. Noises. Noise is a random errors or a variance in dataset, often seen in a sensor data as small fluctuations that don't represent the true change or a measured value. So normally it happens with the sensors. So sensors may give you the noise data. Okay. So it is a random error or a variance in the dataset, often seen in a sensor like a data as small fluctuations that don't represent a true change or a measured value. So these are the common data issues. What we discussed, common data issues is, first one is the missing value, second one is the duplicates, and third one is the inconsistency, fourth one is the outliers, fifth one is the noise. These are the different common data issues when you want to clean the data or generate the data model. So first one is, again I repeat, missing value like causes or sensor failures or incomplete records. We call they represented with the NaN, null or empty cell. And the second is duplicate, which is repeated logs or patient entries. We call them as a duplicates. So solution is simply we remove those duplicates. Third is inconsistency. Okay, inconsistencies like somewhere M is written, somewhere male is written. The solution is somewhere it is written in the LBS and somewhere it is written in the KGS. So same data is represented in different manner. The solution is normalization, right? So the fourth solution, outlier. Like suddenly some values completely different from the normal range. That may be with the sensor spikes or impossible vitals. So what we do, the solution is to maintain the thresholding at Z scores so that we can cut whatever outlier is coming. We will not consider that. Okay. So, and the next one is random fluctuations. So random fluctuations can be done by smoothing or filtering the data. Okay, whenever some random fluctuations are there, we can filter the data. Then what is the impact of dirty data? So all these missing values, duplicates, inconsistencies, outliers, noise, all these are the dirty data, which is to be corrected or removed. So why we have to remove? What is the impact? Mainly, as I said, wrong analytics, inaccurate analytics. So skewed statistical results and misleading trends. Will get skewed statistical results and misleading trends. And poor model performance. So whatever machine learning model we are creating, that model perform very wrongly. Okay. 1 minute. Divya, are you there?
Yes, sir.
So what I suggested you, I told you to do something. Please talk with
Like, please stop
Ganesh.
this slides.
Yeah, you have to stop, Divya. You need not to ask them.
Okay.
See, because recording is going on, that will create unnecessary, because we need to post the recording, right?
Yes, sir.
If you don't know, you ask other team members and do that.
No, sir. I know that. I'll clear now.
So the impact of the dirty data is wrong analytics and poor model accuracy and resource wastage. Whatever we are developing, if it is this machine learning model doesn't work well, then what is the use of creating that model? So it's a waste of the resources. So machine learning models trained on dirty data will perform poorly, making incorrect predictions or classifications. So waste of resources will be there, where time and effort spent on analyzing flawed data is a waste for us. So, and the process may need to repeat it from the scratch. From again, if it is model is not working well, again we have to repeat from the scratch. Okay, so that is the impact of the dirty data on us. So when we are coming to this robotics data, the primary sources of information is, say, it is using LiDAR, we call LiDAR. These are the important terms when you go for client interviews, that you may talk in those terms. Whenever they ask you about data clean, you have to talk in terms of the projects which you are going to do. So, or you need to do. So then they think, okay, these things they know. So LiDAR, okay, that is light detection and ranging, right? So whenever this LiDAR, like sensor reading, the basic sensor reading for robotics is the LiDAR, which provides the distance measurements from to the objects. Okay, use it for mapping obstacles and obstacle avoidance. So it provides, this LiDAR provides distance measurements to objects. Use it for mapping and obstacle avoidance. So what is LiDAR? Again, I'm repeating: light detection and ranging. So this is one source when we talk about the robotics data. The another is IMU, inertial measurement unit, which measures the inertial measurement unit, IMU, which measures the acceleration and angular velocity. Use it for determining orientation and motion. Okay, so this IMU will measures the acceleration and angular velocity. Use it for determining orientation and motion. This is mostly IMU use it for the motion or orientation and motion. Okay, please remember that. And the cameras, which provides the visual data as well as the for object detection, navigation, and other computer vision tasks. And next one is actuated commands. These actual commands records of the robot actions such as motor speeds, joint angles, gripper commands. Okay, all these are the different datas. Okay, first one I said LiDAR, IMU, cameras. These are the sensor datas. Okay, then actuator commands. These are the records of the robot actions, such as how much motor, what are the motor speeds of individuals, what are the joint angles. Right now, what is the joint angles? Or a gripper commands, what you have to grip harder or smoother or average grip you have to do. Okay, so these are the different gripper commands, right? And logs, system logs that record events, errors, and status messages. So these are the different robotic datas. Okay, so logs, actuator commands, cameras, IMUs, LiDARs, these are the different robotic data, right? So this robotic data, when we are working with that, now we'll see what are the challenges where we need to clean the data. Okay, like what are the, like first one is the noisy sensors. So noisy sensors, especially low cost one, can produce readings with random fluctuations or spikes. So whenever you're using the sensors in the robotic and reading the data, maybe the quality of the sensor may be low, or it may be already having some issues, technical issues, hardware issues. So it may give the noisy data. Okay. Then missing timestamps. The another problem is missing timestamps. Data from different sensor might not be perfectly synchronized, or timestamps might be missing or making it difficult to fuse data. So this may be problem. So timestamps may be not correct because we are getting the data from the different sources when we are developing the robotic models. And the third one is outliers from the hardware faults. So maybe depending upon the malfunction, which produce a value far outside the normal range. For example, a LiDAR beam hitting a reflective surface at a specific angle can return unusual large distance value. So this LiDAR beam, whatever we are using for sensing the data, obstacles, maybe based on the reflective service, it may give us the wrong calculations. So that may be the outliers may be occurring due to hardware faults. So these are the normal challenges which we occur in the robotics data. So these are the what we call the not, it is a bad data which we have to clean. Okay, which is a garbage which gives us wrong model, using which we will go for a data models which are doesn't work, or a ML models which doesn't work well. So that is the reason we have to clean the data, right? Why this cleaning? Because we need, if the data we are not cleaning, the navigation doesn't work. Okay, and safe decisions cannot be taken, right? So that is the reason where we need to uh, do the cleaning of the data. So what you SLAM means, simultaneous localization and mapping. Please remember that is the word which we use in the robotics. So the importance of cleaning the data for robotics is, first one is control algorithms. A robot ability to navigate or interact with environment depends on the accurate sensors data, right? So if it wants to interact with others, the data which it is getting to it should be a good data. So single noise can create the problems. So SLAM algorithms build a map of unknown environment while simultaneously keeping track of the robot location. So this process extremely sensitive to data quality, and or noisy or inaccurate sensor data can lead to the drift. Okay, so that is the reason, while the accuracy is needed for navigation, SLAM, as I said, it is a simultaneous localization and mapping. So this is calculated when robot is moving, and safe safe decisions also it has to take. So what we have to do, we have to clean the data. The example what we're taking, we have to clean the data. Say a robot lidar sensor is collecting distance measurement, right? But occasionally it returns extremely high and erroneous value spikes due to reflections or sensor glitches. Okay, there are also moments where it misses the reading entirely. So in this scenario, while lidar is giving us collecting distance measurement, so normally lidar is used for the distance measurements, right? But occasionally it returns extremely high on erroneous values. So in this case, cleaning steps or data cleaning steps using Python is, first we'll identify and remove outliers. Okay, in that we will use a statistical method called Z-score to detect the outlier, and the Z-score measures how many standard deviations a data point is from the mean. So exactly using the Z-score, what we can detect the outliers. The Z-score measures how many standard deviations a data point is from the mean. Okay, so normally a common threshold is to 2 or 3. Any data point with Z-score beyond this threshold is considered as outlier. So we'll take the data and we'll check we'll put the threshold Z-score, we'll take the Z-score, and if it is something from the more information is given, then we'll go for the Z-score removal. Okay, so for that simple, we'll do this practice also. We'll do this also. We'll import NumPy as NP, and we'll also from SciPy stats we'll import the Z-score object also. We'll also import NumPy object as NP. Okay, Then we'll calculate, we'll apply this Z score, initialize the Z score. And if something is more than that, we'll consider that as outlier. Okay, this is a sample screen way how we are implementing this. So using this, we can remove DF by applying this Z score for the data frame, and by simply removing applying the Z score, and if which is more than that, we will remove using the cleanse distance methods and all. So based on this Z score, the first method is based on the Z score, we'll remove the what we call the outliers. The second method is removing the duplicates. Duplicates, simply we can use a function called drop duplicates. Okay, then whatever columns we give based on that, and here time stamp we are giving, and what we are doing, we are telling that to keep the first value when two or more values are occurred on the same timestamp, and then we'll be using the first one. Okay, so here in this duplicates method, I'll try to explain with execution. Don't worry. Right now, let me clear with duplicate. First, we'll explain what is the scenario of the duplicates. So sometimes a robot log file contains the duplicate commands and inconsistent timestamps. One timestamp seems to be slightly off from sequential pattern. So in this scenario, we have to use the drop duplicates function in Pandas. Okay, you can specify which columns to consider when identifying the duplicate. In this case, we are using the both timestamp as well as the command columns. Okay, which are important, and we are by saying first we are removing the data. So in this, first we'll import the pandas. Then using the pandas, we'll create we'll use the data frame to load this data. Okay, in a pandas object. Then simply here df is the data frame, right? Data frame object. So simply after loading, simply we use the function called drop duplicates. Okay, which is where it will be dropping or removing the data. So here the code creates a data frame, then uses the drop duplicates and removes the row where the both timestamp and command match earlier now. Okay, so that is one method. Another is like if we go for this is another problem we call as synchronizing the timestamps. Synchronizing the timestamps. For data to be usable, it is often needs to be aligned in time. So if one sensor or a log is slightly off, it can cause problems to the analysis. So one method is to use a simple linear alignment if the offset is known, or to resample the data in a regular time travel. So what we do, we use the interpolate, or we'll serialize the data, right? So here it is a here in a real world scenario, we will identify and will correct the timestamp names by simply synchronizing the timestamps. Okay, I'll explain this also while executing. Then coming to the health data. Before going into the health data, we'll try to execute few programs on it. Let me show you once I stop recording. Just stop recording, Divya. Let me open another presentation, which where pandas, and I will discuss pandas, few pandas. Then we'll come back and explain this cleaning.